problems and opportunities behind Edge AI. Edge AI is a term you probably heard already several times. So you can think of it as a hype or buzzword. But the fact is that there are indeed many opportunities behind it. There is also a huge challenge for Edge AI deployment. For those of you who are interested in both the problems, the opportunities behind the Edge AI in terms of development and the deployment, I will bring you two interesting angles to look at it. So one is on the trust side. The other one is about the sustainability.
Welcome to talk.cybercni.fr.
Bienvenue.
Welcome to Talk Cyber CNI. Today already the 23rd edition of your favorite cybersecurity speaker series. And as always with this edition, also we want to stimulate your thinking about a very important topic that we find super important in life today, which is cybersecurity. When you think about your environments, you know that there's lots of hardware and software that is connected to computers, sometimes visible, sometimes invisible, and in the series we want to focus on different aspects of this cybersecurity. And today we have a very interesting topic. We have the topic Trustworthy and Sustainable Edge AI. The title that Aaron chose contains already lots of very interesting so-called buzzwords today, but he will definitely tell us also about the meaning behind, and you will see that this concerns really lots of the systems that are surrounding you that you're working with. As usual, we have the second channel, which is the Slido. Let me just switch over picture here. So today is already the 23rd edition, therefore in the Slido we have cybercni/23. You have the QR code here. As usual, you will also see it on each of the slides. So I will show you the 23. And as usual, we also have Alex with us today for the Q&A afterwards. And so we'll see him at the end. And as always, ask lots of questions, because as you know the format already, it's about half of the time presentation of our speaker and half of the time discussion with the speaker. And the more questions we have from your side, the more you can steer where the discussion goes. And as you know, the discussion is equally important or interesting as the presentation, and therefore, really take the opportunity. And even if you're not inspired yet to ask a question, open the Slido in a second screen, because there you can upvote and downvote questions, you can get inspired what the other people were asking, and we're looking forward to your questions. So, topic of today, Trustworthy and Sustainable Edge AI. Our invited guest today is Aaron Ding, and I'm very happy that Aaron accepted the invitation. I know him back from my days at Technical University of Munich. We both moved on. He moved to Delft, I moved to Rennes, and so Aaron is a very interesting and by me admired researcher doing lots of cool stuff, and let's see what he's doing. So Aaron at the moment is leading the Cyber Physical Intelligence Lab. He's a tenured associate professor of Edge AI at TU Delft. He has been awarded EU research grants of more than 5 million euros as consortium director and principal investigator, with over 15 years of research and development experience across the EU, UK and the USA. He has worked at Technical University of Munich with Jörg Ott, at Columbia University with Henning Schulz-Renner, at University of Cambridge with John Crowcroft, and his research focuses on edge computing, edge AI, and data-driven IoT services, giving him the background that he will be talking about. He is an active member of the ACM, IEEE, and IETF. He is the founder of the ACM EdgeSys. He is associate editor for the ACM TIoT and IEEE OJITS. And for contributions to mobile edge computing, his research has received Best Paper Awards and recognition from ACM SICOM, EdgeSys, Sensys, CCIoT, and the IEEE Infocom. More details on his website, so when you go to our website, you see the link to his website. And without further ado, Aaron, I will give the mic over to you, and we are looking forward to hearing about this super interesting and important topic from you. This stage is yours.
Okay, thanks a lot, Mike Oliver. It was actually a long time that we reconnect here. Yeah, it would be even nicer if I deliver the talk actually in your place in France, because I guess now since we move away from Munich, we both move to a kind of a different place, and then I think you are moving to a warmer and more beautiful place. So it would be even better if we actually do this on site. But anyway, the talk today is already, as Mark Oliver already introduced, focus on the two kind of a very, I would say, interesting and also a little bit problematic terms on the general topic for basically networking and computing. So it's about trustworthy and sustainable. And then I will actually try to actually, bring you a little bit closer to, especially within the context of edge AI today, on how we actually tackle this or how we should actually, look at it from maybe an open mindset. So that's actually, what you can expect for today. And of course, yeah, as I already said, this is a bit complicated subject to start with. And you can see here, there is already something a bit weird to open the talk with. But anyway, but that's actually the flavor I want you to get it. Because even as I already show here, we can divide this map, whatever this we call it, into two parts. This is actually a kind of a picture I derived from one of the papers we did recently with John Crowcroft in Cambridge about what kind of the research agenda in the upcoming years that we can look into the trustworthy, sustainable edge AI. So yeah, with this kind of like a background to start with, let's actually go a bit deeper now into the, I would say, the real essence, the beef. So interesting points to start with. Uh, I guess I directly jump into the edge AI subject without even introducing what is that. And then typically from the audience, when I introduce basically my research on this domain, it is always kind of towards two ends. So one side is that the community I'm in cares about it. The other side is that there are people who have little interest. And then if you ask me, actually now who cares really about edge? So I guess that might actually be interesting to bring this flavor to all the audience today that we are going to embrace. So basically to talk about edge, I would say we can actually look at it from maybe from starting from the big challenge that we are facing even right now and also to the coming years. And then this is one of the pictures I typically would like to get you into the kind of the rhythm. So as you can see here, there is a kind of an interesting driving scenario when people are on the cars. And then typically in the upcoming years, we will see more and more advanced, I would say more automated services coming to the cars. And then as I already highlighted here, there is a phrase I say, yeah, how much we actually would like to, let the cloud to actually, decide actions for us, especially in certain urgency scenarios, like on a heavy highway. And then we have actually some kind of, very kind of a hectic situation to deal with. And then this is actually, the problems, just as from the one flavor that we're probably going to see in the future, is that nowadays we have lots of data from the services, both on cars and on other things like augmented reality, XR, things like that. So we are facing actually several things to challenge us in terms of latency. In this case, obviously, and then there is also consideration about reliability, security in the overall framework, and of course since we are talking about lots of data coming from the user, coming from the cars, the behaviors of the all the objects in the picture, so there is also concerning about data privacy in the scope, and of course trust. So this is before we start talking about why should we care about edge, there is something flavor behind this picture that give you slightly a kind of feeling, even if you have no interest in edge or AI or whatsoever. So I would say now you have a sense of kind of challenges we are facing in this domain. Uh, Obviously, we are actually looking at something, maybe let's call it a little bit more forward looking. So what's actually beyond the cloud computing that we are currently fully embrace? So maybe I guess everybody is using cloud service nowadays. Just imagine how many of you are not using Gmail or Outlook or Microsoft services at the moment. I guess that's clearly the case for now. But then beyond the cloud, I guess there are several things people are kind of talking about, quantum, all kind of things there. And edge is some of the phrase probably you start hearing it in recent years. So it's popping up regularly nowadays. And if you talk to me in our community, well, there is actually a lot of things going on. So from my perspective, I think edge has a flavor in it, but then this is not actually a marketing speech for edge. So just to make sure you don't get that wrong. And then, I would like to share with you also observation when we talk about the edge computing. So I started working on the edge basically back in 2015. So sort of around the year when I actually moved to Munich doing the research. And then till now, in this year 2022, there is actually a very interesting observation I noticed. The trajectory of edge. So if you ask me, what will I actually face the questions in 2015 when I introduced I'm doing edge computing. So most most likely, almost like 100%, everybody look at me like, what is that? What? So this is the question mark everybody has. And now, right now in this year, when I start introducing, I would say sometimes I get more of the flavor and of the questions like this. Maybe not like a question, but more like, okay, yeah, well, Aaron, you are working on a hard topic. And then, to be frankly speaking, I'm actually not actually a fan of chasing hot topic, like all kind of buzzwords. I work on this because this is actually my research line. So I'm not sure how I would phrase it. I would not consider this as a hot topic, but then I can get it. Why? Because recently, if you're in Europe, and if you are a PI or research leader, you are looking around for funding, and you look at Horizon Europe, the upcoming computer science engineering, the call for proposals, you see a lot of these edge words, decentralization, next generation of cloud, continuum, popping up all the time. So I can understand why nowadays when I start talking about edge, people start commenting on me either in a complimentary or kind of maybe mocking flavor. That's this is a hot topic. So there is something behind it, obviously. So I would not say it's a hot topic, but obviously it is actually getting some attention now. And then, of course, in the research community, in case you are not in our community at the moment, I would say it is already evolving for several years. And then even in the general edge computing parts, the ones I'm involved, even for edge Cs, we started in 2000, basically 18 from Munich. So that was the first time we actually kick off. And then till now, it's almost like 6 years now. And we are also continuing that with our community growing. And then at the same time, especially in Germany, we have Dockstuhl seminar, and then in Netherlands we have Lorenz. So we also have actually in the last year and also in the coming years, we have interesting Dockstuhl and Lorenz workshops going on this edge AI future computing perspectives. And then obviously, this is actually an indication for the research community. We are actually pretty much evolved on pace. So, and of course, if you wonder why I'm actually working on the edge, so it's just brief introduction of myself, just briefly how I actually ended up on that. So basically now I am working in TU Delft, leading my team, and then I also have a affiliation and permanent appointments in Helsinki Computer Science, where the Linux operating system is introduced and produced. And then in the past several years, I worked across several countries, continents, I would say, on several subjects: mobile computing, communication, offloading. And then the time when I actually moved to Munich, that's where actually I started actually moving a bit away, going above the mobile cloud domain, start looking at what is actually the problem between the cloud and mobile. And then I would say this is actually the phrase where I started looking into what kind of edge domain. So I would say around 2015 ish from here. And then, as we already indicated, I have already observed the transaction of these people, and also the feeling of the edge, and also the real research going on in Edge for, I would say, above 8 years in that case. And then, of course, yeah, now into Delft. I think if you are an audience not actually familiar with the universities in Netherlands, this is also kind of interesting and courtesy for my university. So TU Delft in Netherlands is, I would say, a very interesting university. I can tell you last time when I have visitors from Germany coming here, they actually feel exactly what I feel, because on campus we have a very technical university layout, all kind of engineering buildings, round square, and very organized. And then just across the river you see actually a very interesting beautiful town, and that's actually Delft. And I would say, this is a very kind of a contrast, be kind of a comparison. Just across the river you have a very old traditional kind of Mediterranean town, and then on the other side of the river you have a kind of high-tech campus, which is kind of, I find it quite funny. And then in terms of engineering subjects, computer science engineering, I think Delft is doing pretty well in recent years. And then I would say, especially, I think, when I moved here, Delft has a very interesting graduation. If you are a PhD graduated from here, that's actually the PhD graduation here is a very, very formal. So big different from, the system I have seen before in Germany. So you have actually a huge ceremony, and then even the people actually holding this kind of, a very, very special kind of stick, like, something like feels like you're stepping on your throne on that day. So, and I would say, if later any one of you got invited to a PhD graduation in Delft in Netherlands, definitely take it, because that's a very one of its kinds, I would say, cool experience. And then in TU Delft, I'm actually now running CPI lab, cyber physical intelligence. The focus of my lab is on the edge and IoT. So pretty much, very focused. And then we are actually the founder and running the HCs for several years. And then for myself, I'm also on the editorial board for ACM transactions on IoT. So basically, yeah, that's essentially how the focus of edge and IoT are panned out in my lab. And then, yeah, in case you wonder, where does this kind of, the engineering ranking come from? So this is the most recent engineering ranking globally. I just put it here as a kind of, just for your fun and for flavor. So the top 10 is listed here globally, and then, yeah, Delft is somewhere here. So which is, yeah, I would say doing not too bad in the EU wise. And then, of course, the research I'm going to introduce today essentially come from my lab. And then for the past several years, we have been working on a lot of things centered around edge. So basically building system elements, platforms, computing, design, communication, security, privacy subjects. And then in the most recent years, we focus a lot on the analytics and the service side of the edge domain. And then, yeah, lots of credits go to my current postdoc and also PhD researchers in my team that, essentially without them, all those building blocks won't actually come into actual reality. Okay, yeah, lots of things, excited for me to talk about. But then I would say, edge AI is a thing. Many people have different opinions. So research-wise, I would say research community, we have been doing on this for several years. But then there is always a question, is it just a kind of a research toy that's a group of folks like me, maybe some others, sitting together and then talking about it every day, but it's not actually something real. So I would say that if you have this similar question, I definitely feel it as similar like you feel. Because even in the community, we are having also kind of critical view on these subjects, even in the recent years. Because if you talk about edge, the idea of edge has been here many years ago. I mean, when Cisco threw out the idea of fog computing, that's already some kind of flavor already in this kind of, playground. And then this is one of the paper, I think many of our community people, including myself, we actually critically review this domain, and we published this paper last year on the internet computing in IEEE. So if you're interested into, the new kind of, critics on this edge domain, this is actually a kind of interesting thing. You can just have a quick look, because I would say, question wise, is it a real thing or not? That's actually not the question, but I would say, is it actually a real problem that's out there that needs something like edge AI to solve? I guess this is actually where the paper is all about. So highly recommend for you to actually, just have a casual look if you are interested. And of course, yeah, I would say research-wise, that's just a paper. I guess it is actually pretty hard for me to claim, how important they are. But then we are researchers, we put data here. So you can see here, there is actually a couple of things I highlighted here. What exactly you see here is about, the recent years, what kind of edge computing, AI, hardware, development platforms, management framework that are released by the major companies out there. So I would say this is actually something you probably start probably realizing. It is not an academic toy anymore in recent years, especially in the recent 3 years. So all the major companies you can think of, Amazon, Microsoft, Google, Nvidia, Intel, whatever you have in mind that you are dealing with most daily, they are all in. And then even for Amazon, I would say, I think last year, probably around the last or even bit back forward, they also released this AZ1 Neuron Edge from hardware side chip to accelerate this push on top of all the services they have. So in this case, I would say Edge AI, if you are questioning that whether this is a toy, I would say Edge AI is actually not a toy, but it's actually really coming. So it's a real deal. And then, especially if you are following the recent development trends, it is actually coming very fast. And then, yeah, even for myself, for my lab, we have actually been awarded 2 projects recently up till end of 2024 to work on this. So from European Horizon and also the Marie Curie, the big consortium ITM. So those are actually 2 big fundings I'm running, both as the consortium director, coordinator, and PI at TU Delft. So as you can see, the topic wise, it is also kind of fully developed both on the research wise and also industry pushing ahead. And then, yeah, just to highlight that even if you want to know how hot the topic is, I would not say it, but then the proposal we actually did for those 2 subjects on the trustworthy and sustainable parts of Edge, they are highly ranked. So that's how we actually got funding. And then, from the other angle, you can see this is actually where even the European Commission, they are paying actually quite a lot of attention on these subjects in the as a kind of future investment for all the kind of things we can embrace in the upcoming years. And then of course, yeah, in the end, edge AI is something that industry is doing, we are doing from the research community, but then that does not actually justify, if we are doing that, why we still need it. So in a very simple way to put, I guess many people actually heard me talking about edge in the other kind of places. I always face a question: are we actually doing edge AI in order to replace cloud or replace IoT? So just to be clear, we are not actually doing this to replace. The vision essentially for the whole research domain of edge and AI is to actually consolidate cloud and IoT. Basically, there has been a lot of kind of I would say gap growing from both cloud and IoT sides. And the edge AI is where we see it as a potential kind of target that can somehow, glue and consolidate both. So in the end, we want to make the whole kind of, experience on the cloud, on the IoT, all better for, daily services we're enjoying every day. Of course, from telecom perspective, if you wonder why everybody is actually doing edge. This is actually one of the frame actually from shared by the CTO of Nokia many years ago. As you can see here in the middle, from what kind of telecom view, they view it more from the kind of converged cloud perspective. And then it is actually where you see a lot of, even more buzzwords, programmable networking, all the value added services on top of that. But actually, this is also kind of, a different view that you can start recognizing. It is actually bringing some values, not just for the end users, but it also creates actually very interesting kind of potential venues for telecom to open up new business. So that's why it is actually coming gradually. And then, of course, in terms of edge computing, I guess, yeah, for people who know it, I don't think I have to repeat it. But for you, if you are not unfamiliar, this is probably something you would like to see. So exactly where does this edge locate? And then from general this kind of layered cloud IoT mobile domain, as you can see here from this general kind of perspective, from the system layer view, the edge part is somehow kind of like a sandwich cut between cloud and IoT end devices in the middle. And then if you think about, the research that potentially we are doing, they are somehow, focus more on the edge layer part. And of course, definitely sometimes it is not clean cut. So there is actually crossover to the cloud and also kind of going through and merging with the IoT devices and even some kind of low end devices. And then yeah, I mean if the computing view is also kind of a bit vague physically, if we look at the general kind of devices we're having around, edge computing nowadays generally happens on sort of like the access points, the gateways or base station, what do you see. So essentially it is where one of these first entity when we try to access internet. The edge computing typically are located somewhere in the very nearby to the user, but then wireless communication wise it's like sort of like the first hop that you actually get into the physical infrastructure of the internet. Okay, yeah. So what exactly is this whole thing all about? Edge computing. So there is a location where it happens. There is the whole point of this business behind it. So edge computing actually is something, before we actually dive into the trustworthy part, I think it's very good to for you to get impression. So in terms of edge computing, in a real example, so if you look at the many years ago that we are doing mobile computing, a general kind of items we're doing is that like the smartphones we have, we are basically thinking that there is a battery on the phone, there is a limited kind of bandwidth and also limited resources, we offload things to the cloud. So this is typically the cloud mobile computing general understanding. Everybody probably already take it as it is. But then on the other hand, if you actually take that in mind, the edge computing paradigm is more like the other way around. So instead of actually pushing things to the cloud, nowadays there is a demand either because of latency or privacy or other kind of requirements on the services. The cloud has to offload back something to the edge devices, which locates a bit nearby the end devices like IoT sensors and IoT devices nearby. So this is actually, if you want to see how the edge actually is organized, this is a very, I would say, simple example for you to get a sense of that. And then, yeah, to be more specific, if you think about how that is really done in kind of, more kind of a computing flavor. So you can think of the logic application, intelligence logic in the cloud that, they have actually can be regarded as a box, like a Lego box. You chop them, and then for edge computing, that's for some of the computing units, computing boxes, and because of the latency requirements, we actually can shift them bit closer on the edge device, which actually directly face the IoT resources, and then they can actually directly handling collecting data and also giving the instructions actions directly on the data directly. So this is in that sense a kind of a, I would say a simple way to understand the paradigm of edge and AI. And of course, talking about that, it is quite kind of weird if things just moving back and forth, ongoing, and then this one is sitting there just like a proxy. That's actually not the purpose. The real purpose of the edge and intelligence services here is that when things happen on the edge, you are able to actually directly operating on the information and then start serving the users the services nearby edge devices. So just give you a kind of more concrete flavor. That's what I have been working back in the days in Munich and even right nowadays. Is that if you can think of a road infrastructure that like traffic lights, lamppost. Nowadays there is actually a lot of things going on to empowering this part to support future driving services, pedestrians, cyclists on the road. And then there is sensor, there is light, communication, and computing already embedded on this kind of physical device. So if you ask me, physically, how does edge sometimes look like? So this is I would say a kind of a realistic example. And then if you look at here in the United States, actually, this telecom companies are already also on the move. So this is actually a 5G smart cells mounted on the kind of traffic light. As you can see here, this is already kind of in highly integrated into the infrastructure where computing, communication 5G is embedded into one box on the physical entity on the roadside. So the picture is actually from Wisconsin in the US. So this is not some kind of futuristic stuff. It's ongoing. It's real. So for this whole thing about the edge, as you can see here, edge actually can provide microservices to actually support certain kind of scenarios like driving on the roadside. And then because of the latency and privacy and some of the advantages they have, they actually can, enabling certain kind of advantages that we can embrace future kind of vehicles, kind of drone services, and also augmented reality type of, these multimedia services. And then, yeah, even in my group, we actually did a design several years ago that basically, by empowering the different lampposts along the road in order to detect black ice formation on the road, basically by splitting the kind of sensing functionality across different entities. And then even for that, as you can see, we actually got the paper awards from HCs back in 2019 for this kind of work. So, things actually are moving quite rapidly. And then, as you can see, we do have actually a real case in this domain. But then now, yeah, several things has been already kind of dropping on your plate now on the edge. And then it seems that now we are trying to bring edge AI, basically all the intelligence to the middle, to the edge. And then some of you, if you are critical enough, you might actually have a kind of, bit worried because previously we say, okay, lots of things happening, going to the cloud, going to the IoT, that's problematic. But now it seems that now there is another wave to push things to the middle. So obviously, does that actually solve the problems we have? Is that actually a realistic thing that actually people can criticize? And also, even more than that, when we push things to the middle, do we actually also actually somehow reveal or actually create more problems? So that's actually, the things people actually in our community, they are very actively working on. So I would say, if you want to, for edge computing, we are not, for this community, we are not actually like these believers that think, this is future is edge is everywhere. No, we do see actually problems and being critical about it. So also last year when we gathered in Darkstore, we are thinking about, what is exactly the problems that, hindering potential future edge to go forward. And then this is one of the paper we actually recently released about the roadmap to go ahead on the edge AI part. And then if you actually pay attention here, lots of things actually have happening recently on this kind of, the roadmap we start actually collecting from the industry and the kind of a community from both sides. The framework computing elements, this has been actually going on for many years. Computing parts, elements from the industry, research design from the academia has been pretty much going on. But then at the same time, there is actually a couple of things actually start appearing and raising up. So as you can see here, trustworthy problems, sustainability problem, and then there is a infrastructure equal access, which is actually a bit more kind of geopolitical type of thing that we still need to actually not yet fully kind of realize and also know how to actually handle. So those are actually the perspectives I would like to show you to start before we start actually digging further now. In this case, we have the roadmap here as a kind of one type of flavor how we actually positioning future challenges in front of us. So I would say very urgently, there were two challenges, which is the topic of today that I'm going to actually bring a little bit more details. So trustworthy parts and the sustainable parts, that's what we also defined as a very critical and also maybe tricky problems on the edge, especially on the edge for AI to actually bring new values. And then this is actually the sort of like, some of the things we open up the research starting from maybe a few years back and then officially actually, position that work starting from last year's Darkstore. And then of course, yeah, I mean, now the same picture you can see here that we already know. Even things moving from cloud back to the edge, for example, some compute units on the car. So the same question still we cannot get rid of. Even the intelligence happens on the car. Do we really trust this device that actually can take over the actions on behalf of a human? So how much we can trust? So if there is a problem, who is going to be accountable for that? So, and how transparent do we know exactly what is happening there behind all the machine learning, deep learning algorithms that actually come up into action points? So trust is actually something we realize, even though now all the computing units, hardware, and NVIDIA is actually releasing also a lot of things now in the hospital, empowering their NVIDIA edge there. So, but then this trust issue you can't just get over easily. And then this is actually a demand. We think that for trustworthy AI to be actually very seriously, we need to actually handle them on the edge. And partially it is because of the pervasiveness. So comparing with the cloud, edge is sort of like a bit closer to us, to the end user and also the data where uh, is generated. And then, of course, more sensitive the data, more carefulness, more trust we have to actually place. And then the other problem is that compared with the cloud, which is nowadays managed by entity companies, where there is actually a well-regulated standards, regulations to control the environment, operational environment. For the edge, many people probably don't realize that when you push things on the edge, it's actually a bit more kind of distributed environment where I can highlight it as kind of sometimes uncontrolled environments where we actually lose kind of very hard protection, like the cluster, the walls behind cloud, and then that's where things gets a bit more tricky. Even though we think that edge has a lot of value, but then it also has this kind of something we cannot actually omit. And then, of course, why we now start looking at edge, partially is because now we have the frameworks, we have the hardware industry, academia coming together to push this forward, potentially for a large scale. But then there is actually still pretty much unexplored domain in terms of this trustworthiness of edge AI. Because in the community, as you can see here, in the AI community, the machine learning AI trustworthiness, it has already kicked off for back several years ago. People talking about potential bias, transparency issues in AI, black box issues. And then on the IoT side, there is also similar work from the more kind of embedded system community. So this is going on. But then kind of the kind of in the middle part, the edge AI part, this is where we are now at the right point to actually look at this problem with a realistic assumption and cases. And then this is actually where, for one of my projects going on at the moment, we are looking at this trustworthy edge AI for this spatial project that where I'm the coordinator leading this consortium. So the question is that we have a project and we have a problem space. How we tackle this trustworthy problem? That's actually something very tricky, and I'm sharing with you some of my latest experience when running this project, handling this, because it's not a simple subject. So first thing first, the project we have actually gives some flavor because we have working closely with companies like F-Secure and Telefonica NEC and with across different university in Europe looking at this problem, and then which give us more kind of use cases realistically to actually evaluate the design. And then we actually also wrote a paper together with our colleagues internationally to look at actually the problems in this domain. So the problem here is that for trustworthy, there is actually a big issue how we actually locating the problems we are going to tackle. So in this case, I would say the detail wise, I would highly recommend us and especially you to read the paper in detail. But then as you can see here, in terms of trustworthy AI, there are three parts: transparency, fairness, and the robustness that are actually pretty much important as an enabler. So in terms of if you are academia, I would say in terms of design parts, those are the focus that where we can contribute to actually develop frameworks, develop algorithms, extensions, matrix to help on this part. And of course, in terms of to avoid things going too wide, there is also a scoping issue. And then in this case, for the edge AI, there is actually three interesting scope. You can actually locate yourself, from the data angle, from more kind of context identity angle. Because I think in edge computing, sometimes the trust is not about human. Sometimes it's about whether the one edge computing device trusts the other device, and also even more forward, whether the software, the algorithm on one device trusting the other device and algorithms running on top of that. So this kind of identity trust also happens also. It's a very good, interesting scope. And then of course, lots of things go to algorithm and the models. And this is very classic machine learning kind of trustworthy parts that we need to handle. And then yeah, of course, things we are looking at here, this is just show you, when we look at this problem, just to give you a more realistic flavor, how we can actually break in. So something I want to highlight here is about fairness and bias, because if you think that this is a subject bit different from general when we talk about security privacy. We have actually a lot of things when you have machine learning start shipping them on the edge, the fairness, the bias, discrimination parts immediately come into kind of visible kind of a scenario. And then one of the things that we realize is that we have to understand this. But then the problem is that this is actually not kind of generic buzzwords. We have to look actually specifically case by case. So in the project, we actually select two case studies that has been already ongoing. So one of them is about the pervasive voice activated services like Echo, Amazon services, Google services, where you actually use your voice to activate services. And the other one is about more towards the vehicular services, where we have a lot of data collected by the cars to be shared within the providers in the cloud. And then those are the two cases actually, we have been investigating. So I'm going to show you something we actually recently digged out. So first thing first, for the voice case, I would say, well, situation is actually pretty poor and not very good based on our recent investigation. So as you can see here, based on the recent investigation, we actually find the bias actually exists at every stage of the development, even for one of the famous Vox Celeb speak recognition kind of data set. So all the whole thing of across the pipeline, the model building, data generation, implementation, we find the bias in all the phases. And then, yeah, maybe just to make it more realistic uh, in terms of human perspective. So the female speakers, when we are handling those services, and also non-US nationalities, we have already observed very significant performance degradation if the intelligence are running on the kind of embedded devices, a bit more kind of away from the cloud. And then this is actually kind of a bit weird kind of fundings, but then yeah, we already kind of push the publications out. And then for those, if you're interested, it will be very nice for you to also check for so about bias in automated speaker recognition, where we actually reveal the bias, where does it happen, and how potentially we can alleviate. And then there is also several follow-up work that, as you can see here. And then at the same time, the other case, be different from the voice about vehicles. It's also similar because from this one we look at a bit more close to the data set. So we actually find out now there's many of the open data sets that people use them to train all kind of object detection on the cars. There is actually quite a lot of bias towards kind of vulnerable population classes in driving that we call pedestrians and cyclists, by the way, on the road. And then the data diversity is also not very good. So we have seen actually, especially these kind of vulnerable classes, they are very less represented in all the data sets we tried. And then one of the recent discovery will actually already get kind of accepted. So it will appear by the end of this year regarding bias that we how we detect already inside all the kind of algorithms people using to actually support potentially future autonomous driving. And then yeah, some reflections here to show you that in terms of all the kind of trustworthy side, as you can see, it is essentially a social technical problem where we have seen actually you have actually to across AI community, IoT community, and even social science. And it's actually service dependent. So in that case, if you are from different community, it will be very nice to hear you are actually the use cases and domain, because different case actually provides different values to actually how we actually can approach solving the trustworthy problems in terms of fairness, transparency on that. And of course, I say here that we at this stage we can't give in, because if the problems that we see in the cloud side on the all the bias issues already out there, if we do not solve them on the edge as early as possible, the problems will be propagate and kind of somehow already spread very fast from data set collection from the training, from the all the deployment parts. That would be pretty much a bad situation that for the future, if we say edge AI will be useful in services, but then what if it is actually unfair? What if it is biased? And then at the moment, research-wise, we actually are really need for serious evaluation toolkits, different kind of matrix, how we evaluate fairness, bias, transparency, and robustness, and then also kind of having some benchmarking tools and for evaluation for people to understand, developers especially, how we do that properly on the edge. Okay, yeah, so that's actually very quickly a flavor on the trustworthy side. So the other problem I'm going to probably cover it in a lightweight fashion is about the energy side. So for this part, I would say nowadays people actually already realize in Europe that we are facing kind of a huge energy crisis in probably from this month onwards into the future. And then unfortunately, if things moving to the edge, we do not solve them properly, we will also have the same problems going on the edge, making the energy problem even worse for us. So that's why in the kind of the forecasting, I mentioned that winter is coming. So this is actually also kind of a sign that we need to handle this problem also as early as possible. And then yeah, how serious the problem it is. In terms of energy consumption, just some quick overview for you regarding the training and also of AI models. So this is one of the paper released on the ACM communication recently. That's the all kind of models. The bigger they go, the more generalized they go. The increase of the energy is actually growing every 3 to 4 months, double. So this is actually sounds actually a bit maybe not that kind of scary, but then if you think about the scale, how many models are being kind of deployed, running constantly on the cloud, the energy actually is growing very rapidly. And then there is actually one of the kind of the figure, pretty kind of pessimistic, I would say. They say that if we keep on like this, by the 2040, we might actually on the computing parts, we might eat more energy than actually the energy can be produced on the planet. So if we just keep on like this without any optimization, any kind of actions taken, so this is actually a kind of a serious problem for the globe, and especially in Europe, that we are facing actually serious energy crisis in the coming years. And then, of course, yeah, on the landscape, this is the problem where we look at the right hand side, where we're actually looking at power saving and potentially other kind of energy related subjects. And of course, the whole thing about sustainable is not a slogan. The energy optimization on the edge, we have to actually handle the entire pipeline. So across data acquisition, the data transfer, communication, the computation on devices, and also when we have the data, we need to store them, right? So those are the things actually people tend to actually sometimes take it for granted. But then energy-wise, they are all counted. And then regarding the items that we actually can solve the problem, there are some, I would say 3 indicators we can think of, from the power saving part here. And then nowadays in Europe, we have this kind of also very active research on the circular economy, which is actually also in line because imagine all the devices, all the kind of equipment we have. It's actually good to have actually a more kind of circular kind of usage of the data, of the hardware, of the, all the kind of, life cycle management of that. And then of course, we can't do things just completely on the technical front. So we have to also take the actually the social technical perspective in terms of how to make the users, developers also engaged into this sustainable design part. Because no matter how hard we talk about it, if nobody cares about it, no developers actually put any interest on that. This is just a slogan, and will never happen actually. And then that actually comes to the second project. Actually, I'm actually actively pushing very energetically on the sustainable parts in the Marie Curie. So the service I want to show you quickly today is that we are looking at one interesting angle about sustainable services on vehicular. Most likely in the future we have more and more kind of electronics powered devices like cars. If you think about it, sometimes I would say it is more like kind of a similar trend, the more of smartphones. That the car actually is sort of like more and more a battery powered engine device that can move, and then you will later see more and more applications running on the car, which is kind of like an ecosystem, not similar like the app ecosystem, but then there is kind of like that, if you want to put it more kind of in a computing flavor. And then, of course, the concerns for the cars, they are very real, because some of us may not realize that nowadays the general smart cars, they are generating huge amount of data that needs to be communicated, to be computed, stored, and then that actually directly goes into the energy consumption. And if you think about the battery life, that's more like if you're using a poor battery powered car, and then if you're having all loads of lidar and all the communication service running on, you probably cannot drive over an hour. So that's very realistic kind of items that the data actually provides value, but at the same time costs a lot of kind of energy. And then, yeah, one of the picture many years ago when Intel showed this is like, even I would say 5 years ago, they already say every car every day they can generate 5 terabytes of gigabyte of data, which is nowadays I will show you another figure. So more realistic in recently, uh, for the cars actually nowadays the figure you are looking at it or we are looking at is more like 20 terabytes now, and this is already a bit old data. I would say it's like 2 years ago when this table was released. So in this case, the battery life really matters. And then, but I already mentioned you can think of the car like a smartphone, but then they are not exactly like a smartphone, and that's where the tricky parts actually really troubles people for both industry and academia, because how we tackle this kind of vehicular service energy saving, which will actually produce a lot of data, eats a lot of energy, how we actually tackle that. So that's where the Marie Curie, where we have actually now 15 PhD working on this subject, and then from 20 plus industry partners coming join force with us on the using approximate computing for this energy angle. So yeah, that's the direction we are looking at. So in this case, the problem we are facing actually is quite straightforward. We do have a tricky dilemma here when we look at cars, because car is actually a little bit different from smartphones, because it's about safety, about life critical cases. And then when we actually compare that with energy saving, that's where things get a little bit kind of hard to digest, because sometimes at the beginning when I start doing this research, I was actually very brave. I said, yeah, can we strike both? Let's try it. So both safety and energy saving on both sides. And then that's where we actually hit a lot of problems when we started working on this subject, because one thing to take away immediately, there is no free lunch. To strike both, there is actually a huge price we have to pay. So in terms of these kind of services, we realize actually after working for some time, it is very difficult to strike both. Actually, the problem is that for energy saving, we need to find actually a very sweet spot on the car services where we actually can tolerate some kind of accuracy loss and the latency in order to have actually energy to be saved. But then safety critical applications, they are latency and accuracy dominant. So you can't basically do that. And then in that case, this is more like, using this kind of an easy, understandable example. We need to actually find a balance between the quality and energy cost. And then typically, the higher, the more accurate we go, the more energy we come. And then it is more about, kind of a balance we have to make. And then in terms of services, it is always the case. How good is good enough? So how much we can save the energy and how good the service we can still accept. And that's actually where we actually start, looking at the real thing actually. When we look at actually car services, we realize actually we should start looking at the data intensive services at the beginning, not safety critical services, because that one, it is pretty hard for us to strike both parts. And then the cool part of data intensive services for multimedia, there is actually a sweet spot where there is a kind of a latency tolerance on the accuracy, for example, the image quality. Sometimes the human eyes can tolerate some. And then for that kind of sacrifice, we actually can gain some energy benefits. And then this is where actually we actually push forward in terms of looking at the streaming services on the car, and also similar together with the edge computing, where we actually can offload certain operations to the nearby base stations where they have computing units. And then approximation is where the energy saving technique on the machine learning models that we are trying to actually push forward. So this is where the combination of the both sides, we have been doing lots of measurements recently, and then the recent ones we actually already push out a paper on this kind of offloading design, but then there is a lot of ongoing parts still at the moment running on this energy parts for this. And then there some reflections I want to share before closing the talk is that there is actually looking at the sustainability parts for the services on edge AI, we need to focus on the right targets, because there is a problem at the beginning. Many people look at the problem, sometimes we actually being too brave, try to solve the problem that's impossible to solve. For example, at the moment, it is very hard to actually take care of the safety critical services. At the same time, bring down the energy consumption, because if we have to choose both, what if safety or energy? I guess most likely for human life, we are more leaning towards the kind of the safety part. And then basically, yeah, there is no free lunch that we can swallow both. So the interesting part is that at certain points there is other type of services like data intensive services that are not safety critical, and those are also the services eats a lot of energy, and those are probably very nice targets for us to look at first. And then if we are managed to save some energy on that portion, it is already a contribution to the overall energy saving for the vehicular services. And then, of course, this is the journey we just started, because the project will continue till the end of 2024. And then my PhD researcher is also currently working at Telefonica for his internship. So we are now also working closely with industry partners to go forward with this direction, because it's also kind of very important subject, not just for academia, but also for all the industry partners. Okay, yeah. To take away, so today's talk, I want to actually bring you awareness about two type of things on edge AI. One is about trust, the other about is sustainability. And then we have a lot of items in the air. So it is very good for us to actually focus on certain parts. And then the future, of course, I say we have a lot of challenges to be tackled. But then at the same time, we also having, just now you see there is a very active community evolving. And then pretty much actually, I would say if you are working in this domain and if you're interested in kind of the future services, IoT, clouds, edge, that would be very nice for you to actually look into the kind of research and design that coming from our community. And of course, yeah, in that case, this is a roadmap people can, sometimes just, for casual look that you can also reflect on. So this is not the only map, and there you can be open-minded. There will probably different track people can look at. So we are taking this look from the cellular, from the cloud, from AI track. But then there could be another one. But then this is also something at least as a kind of food for thought. And then the two projects, I'm very open that in case you are working on cybersecurity subjects related to trustworthy AI, related to energy saving parts on machine learning deployments on different kind of services. Yeah, those are the active projects I'm running, and very open actually to answer your questions. And also if you have any other ideas that you want to work with us, very welcome. So, and also of course, what's next? Nowadays we are in the upcoming weeks, we have this IoT conference in Delft. So in case if you already plan to come here to visit us, that would be very nice to have a talk together. And then next year we will also having the edges, and then it will be in Rome if that's going to happen physically. So I pretty much welcome if you are now interested in doing edge AI system development services, and if you are already doing that, definitely consider submitting a paper to our venue. So in this case, yeah, Mark Oliver, I already finished all my slides and talk. So thanks. Okay, I think I can stop the sharing slides now. By the way,
Okay, so Aaron, you're back. Great.
Yeah, I'm back.
Wonderful. So yeah, great talk, wonderful talk. Let me just switch the view for a second. Yeah, big applause from my side. It was wonderful talk, and I am really impressed, especially how you managed to get your CV and all your projects and a perfect introduction to edge computing and the current challenges into the talk. So really, really good. While Alex is getting ready for the questions, let me start with the first one. So, as you said, we had first cloud computing, then we transitioned towards local and edge. And you said it already in your talk, but maybe I ask you again to say it even more clearly. So, who are the actors in that game? So,
Yep.
if I am now imagining I'm a student or I'm someone a professional, I want to deploy an edge service. So whom do I need to involve? And obviously the question goes also into the direction of the cybersecurity because all of
Yeah.
the actors are potential cybersecurity threats.
Exactly, yeah. Especially from the cybersecurity angle, I would say the major stakeholders, one of them actually pretty funny is that, people tend to think cloud is the enemy of edge, but then actually cloud providers, Google, Microsoft, Amazon, and they're also kind of a new startups for doing kind of new cloud services. They are actually pretty much the strong stakeholders for edge future edge deployment services, in terms of a new chip design, new computing stack, and also tiny ML kind of this kind of design deployed on kind of very much low resource constraints embedded devices. So from the industry side, cloud is actually, all the traditional one players, they are now kind of putting a lot of efforts. So that's one part of the stakeholders from students. If you think about your future, if you select this subject and then, doing that for your thesis or for projects, what's afterwards? That's one. The other one I mentioned slightly in my talk is that cellular providers, they are also very, very much engaged in this now because as you can see here, typically the cloud providers and cellular providers, they are not the same player most of the time. So even though there is actually some kind of crossover, like Google is deploying infrastructure nowadays in the United States, but then most likely in Europe, they are separated. And then if you look at the big operators, Vodafone, Telefonica, and then, T-Mobile and things like that. From that side, the cellular infrastructure is the new edge from that angle. And then that's one of the big stakeholder in case the students, computer science engineers, want to actually work for the future in telecom business. The telco edge is a big kind of a game. And then the stakeholders from different operators, they are also a major stakeholder. So those are kind of, on the high level, big players. And then from the more kind of closer to the user side, the infrastructure providers. So for example, the different kind of, traffic and road infrastructure operators, public sectors managing those infrastructure, they are now also working closely to deploy intelligence on, for example, like the lamppost, the traffic lights, to embedding sensing device communication boxes together, and then they run algorithms on that. So they are also kind of major stakeholder interested into know more about the potential of deploying edge type of services, object detection, accident prevention, and then also kind of urban monitoring of particles, fire, population monitoring, these kind of things. So the public sectors, they are also a big player and also major stakeholder. So yeah, at least I can give
Mhm,
those three, but I guess we don't have to even go further because
mhm,
once those big three are already kind of growing, they were like a gravity law. They will attract more and more
mhm.
stakeholders. And now, even like hospital, healthcare, they're also following up. So
Mhm. And when you come now from a risk analysis point of view,
yeah,
having such multiple stakeholders that are barely connected because I mean they are connected for the service, but they are not connected in terms of services in the sense that when I want now to have a service, it's obviously spanning through the different layers that you
yeah,
just said. So do we have to rethink cybersecurity for edge computing, or do we already have the
Exactly.
methods?
Yeah, it's a huge problem actually. That's essentially where people actually a bit lack of trust of things on the edge. It is because even though we always think that computing closer to user is more private, but then does not necessarily mean it's more secure because the attack surface already kind of is a bit different from the cloud. And then you also have a new entity in the middle of device and the cloud. And then problems can go wrong across different layers on the communication channel, on the kind of data storage part, and then also on the the system deployed on the edge devices. And then and also especially now if you look at more kind of a machine learning flavor, the data you train the models to be deployed on the edge. Because nowadays it's more like a federated fashion to train the things. And then there is a lot of kind of disparity how useful the model the edge can be powered, and then how much kind of bias how much accuracy loss they already entail, because on the edge it is not like a cloud you can just having 24 hours non-stop energy and also endless memory. It is embedded device, to be frank. And then that means that you can't run all the high-end fashioned quantum powered protocol for security. So yeah, that's actually a big problem for cybersecurity researchers to look at, because I would say the trend is already going. That industry is pushing towards the edge, and then that's kind of like opportunity for cybersecurity researchers because now there is a new playground on the edge where there is a new potential kind of uh, remedies, mitigation schemes. We need to actually start thinking, design, develop for the edge enabled services, and then the hardware, software, and also all the kind of I would say machine learning introduced complexity. Those are all kind of translating to cybersecurity problems can be. So
Hmm.
yeah,
Okay, very good. And with that, I hand over to Alex, and I will also jump in a little bit for some of the questions. But
yeah.
we have about 25 to 30 questions. So Alex,
Oh, okay, yeah.
as, as usual, has the super difficult job of grouping and selecting them, and he's always doing a great job. And like that, hand over to you, Alex.
Okay, thank you, Mark Oliver, and thank you, Aaron, for this very cool presentation. So I said, Mike Oliver, I will regroup questions, and you've already answered, give some answers. So some of them, you could pass them if you want. So the
Okay.
first one is for definitions. What are the differences between edge, cloud, and fog? And is there
Ah.
any relationship between edge and peer-to-peer? And a third question, does there exist a link between quantum computing and edge computing?
Mhm. Very good one. So maybe I can't probably answer every one of them, but yeah, I tried my best. So first thing, what I remember is that it's about the difference definition between clouds, fog, mist, whatever. I would say the definition is not actually the points to be start with. It's the problem that we need to tackle. That's actually the focus. And then draw the lines. I would say it's more like draw the lines on the sand. So in terms of cloud, edge, and IoT, maybe I can be also be more brave. I'd say maybe later the line will be even blurred in the upcoming years. So we would not actually have a very clear definition or distinction between the clouds, edge, fog, mist, IoT, and because that's actually where the trend is going, what we call continuum. And then if you really want to know the definition, or I mean draw kind of artificial line there, I would say kind of edge is kind of the term I'm using is a little bit kind of a comprehensive term that somehow includes the definition Cisco and many other academia we already talk about fog mist. They is kind of all included. And then within that, in that big kind of a bubble of edge, we have kind of a higher end computing devices, uh, for example, running on the base station, somehow shipped by Amazon, Google as a kind of as their far reach small cloud. And then across the spectrum in that edge, we also have kind of very low end devices that actually are attached to certain kind of devices like cars that they actually help to compute and execute certain tasks on behalf of the car. very close to the device, to the user. So in that case, there is actually, I don't think we need a definition, because I have been, very kind of interestingly observed so many arguments in the past, I would say 7, 8 years. People just argue about the definition of that for a few hours, but then in the end, it does not make too much sense, because, like I said, it is the problem we need to solve that matters, not the definition itself. And then that's the definition
Okay.
part. And then the second part is that how's that compared with peer-to-peer computing? That's also a very good question. So peer-to-peer computing is more like an ad hoc type of design that has been there for, I think, more than 20 years, even before the cloud. And then edge computing is not fully overlapped, not kind of in comprehend. It has some kind of a overlap with peer-to-peer. But then edge computing actually somehow they can run powered across edge devices in a peer-to-peer fashion. That's possible. So different base station, they talk to each other. That's okay. But then different from pure peer-to-peer, edge computing device has directly access to the internet. So they have backbone as sort of like a fallback. And then in that case, they have infrastructure behind edge. So in that case, it's connected. And then it's more like a kind of hybrid peer-to-peer centralized mode, if you would like to treat edge in that manner. So yeah, in that case, peer-to-peer is related. They are not completely overlap with each other. There is actually a bit of sharing concept depending on the mode when the edge is kind of operating. And then the last question, the third one you actually mentioned, is about maybe, for example, the computing parts and also the content CDN type of thing. So that's actually one of the motivation at the beginning, where uh, the cloud providers start really pushing a lot of hardware design for edge domain, because content delivery is also about the latency, how fast we can deliver Netflix movies, Amazon Prime to the user. Then that's actually the latency part, where there is a need for pushing the storage, the data closer to that. But then at the same time, one thing that edge computing has a different kind of focus, because edge computing is more like, for content provider, it's more like a downstream. So you have a device, and then the content flows downwards to the device. But then for the edge computing, there's a bit more dynamic. That edge typically collect the data, they extract data from the end user and device. They process them, and then sometimes they train the data on top of the data. They share something with the cloud. They push something back to the user. So it is kind of a different kind of operation direction compared with just pure content storage and content delivery. So even though edge computing has conceptual wise, they are completely okay to be placed on the content delivery, because that's part of the thing. You have something directly located nearby and then sending data to the user. And that's actually, I don't see that actually as more like a conflict, but it's more kind of a different way, because content delivery is about content, and edge computing is more like a different paradigm of organizing where the data is executed, and then how we utilize the data for all kind of other services like machine learning training, and also other kind of value added deployment. Okay, yeah, I guess I hope that answered
Yeah,
all three questions you have.
it's more
Maybe
clear now.
maybe let me jump in there, Alex, before
Yeah,
you go to
Yeah.
your next question. So at the beginning, when edge computing was coming up, we had the situation that we had these telco providers, and at the beginning they were providing services to users, and
yeah,
then cloud computing was coming up, services like Google that are not necessarily everywhere a telecom provider, while making the margins and getting the money. The telcos became kind of a bit pipe. And from a business point of view, edge computing, of course, makes a lot of sense, because the telco providers are obviously the natural ones in the communication path between the service far from me and the service close to
mm,
me. Um, my question is do you see today that there's a monopoly, in the sense of that when I'm with my telco provider A, this will be the one I will be paying for the edge services to really have low latency, or are there like interfaces that you have other service providers that
mm.
can get in?
Yeah, that's a very good. Yeah, it's a kind of also dangerous kind of things typically, because we always say that when certain monopoly happens, either by cloud or by telco, then the service becomes a very poor, and then you start to actually have to pay by package, pay by everything. Yeah, and I would say at the moment, edge computing actually opens a different kind of playground where what I observe is that both cloud providers and telco, they are fighting at the same time on this ground, and then that creates actually for customers interesting values to be to be enjoyed, because uh, both big players, they have different kind of interesting business model, and also how to use the data, how to kind of build on top of that more advanced service, and also maybe attract more users, customers in their kind of under their umbrella. And then at the moment, the edge computing is kind of I would say more for telco providers are bigger demand, because in the past several years, I guess most of the telcos are complaining they become a pipe, and then the real interesting data actually flow directly from the device from Android, from Apple to the cloud providers controlling the data. So and Edge now opens up a very fresh kind of uh, new kind of market for them. So they are pushing a lot. And then, but at the same time, one thing probably we also maybe Mark Oliver, you realize cloud providers, they are not actually just wait and stand still, and they are very much jumping on it now. As if you look at recently, Amazon and I would say in particular, they have a whole ecosystem start building up on the edge kind of framework. Starting from their AWS, but then they are pushing that more closer to the shops, to the delivery sports, to actually all kind of I would say closer to user operational environment. And then in that case, we might see some monopoly uh, start growing, but then at the moment it is probably on the edge, not that easy to see. And then I'm actually looking forward to see how far that actually this competition between clouds and telco on the edge can continue, because that's where innovations typically happens. When you have actually very fierce computation kind of competition, we are the ones actually enjoying the kind of uh, the germs produced by this innovation competition. So yeah, I hope monopoly won't actually appear so soon in the upcoming 5 to 10 years, because
Mhm.
this is a new playground. If you think about 15 years ago or even 20 years ago, before cloud becomes mature, and then before the first wave of cloud becomes success, we are now for the edge at the same kind of phase now. So there is a lot of doubts, there is a lot of questions, and then yeah, different kind of opinions. But then you also see that there is clear benefits, business opportunities, and then industry is actually now, at the beginning nobody realized, and suddenly you see a slope growing. Yeah, and then I guess we are now at almost approaching that kind of climbing up years, very much closer now. So.
Very, very good answer. And I want to let me just rephrase again what you also said before. This link between the CDNs and the providing of data. So the advantage of the CDNs was that they were able, I mean, there were not so many CDN providers, they were able to provide the infrastructure close enough and everywhere. And as you said before, the edge computing paradigm is you provide resources that service providers can use. And therefore, I would agree also with your assessment saying, like, okay, at the moment, it has a big chance to even democratize more this space closer to the end user because it's offered as a service. And therefore, something when you wanted to create your CDN 15 years ago, 10 years ago, it was impossible if you didn't own
Mm.
a backbone or something. And with edge computing, you now have access to the spots where the CDN providers 15 years ago would have provided their services. And therefore, it's I also find it very interesting.
Exactly. Yeah. This is where people now actually are start looking at programming paradigm actually to enable kind of end user, also programmers, to actually provide better interface for people to, even from the end user side, to actually open up the edge kind of platforms to be actually attracting more kind of services to be actually later coming up directly sitting on the edge to. And you never know what kind of services in the end we are going to witness on the edge. because now we are just opening the platforms slowly, and then this is at current phase we are more kind of in the phase where there is a hardware starts getting into shape that can be used to power edge services. But edge service is not fully yet in its kind of killer app shape yet. So because I think back to 7, 8 years ago, everybody's asking me, what's your killer app, Aaron, on the edge? At that time, it's very difficult to answer that. So now we start seeing some kind of interesting service idea, business opportunity on edge, but then still not yet. Like what I said 20 years ago, if you ask people, what do you think about the future cloud business? People laugh about it because at that time, 20 years ago, there is no kind of Amazon AWS. There is no kind of a whole chain of kind of cloud ecosystem. And then no business actually is ever thinking about, I'm going to rent something from Amazon. Yeah. So at that time, if you just being very cynical, talking to the academia, everybody's kind of laughing at it, saying that, okay, yeah, what are you talking about cloud? Is this actually a FTP 2.0? What's the point? So I think, yeah, same kind of things I can also observe nowadays when people are very kind of critical about edge. But then that does not actually kind of directly devalue the potential that there is still some opportunities that are waiting for people to explore on this kind of new kind of computing layer, communication layer in the middle. So
Okay, Alex, back to you.
Okay, thank you, Mark Oliver. So you answered already a few questions, so it facilitates my job. So about killer apps that does not yet exist for edge computing, can you give an order of price of the pricing of some specific apps, or maybe the mean price of some apps to use edge computing on some services or platforms?
Oh, this is a very interesting question. Yeah, I would not actually put any price tag because yeah, from academia, I would say this is kind of against the principle. But then yeah, why the guess I can always throw some crazy words. But then yeah, but that doesn't really count. Uh, but then yeah, on the other hand, regarding the maybe not about the killer app, I don't like people call this killer app. What do you want to kill? I don't know. Yeah, so about services potentially on the edge. That's actually another interesting thing that's actually worthwhile for software engineers to think about on the edge, with regarding to all the potential requirements on the edge. And then I have seen some services that my partners, collaborators in the academia in the industry have already been exploring. I can say one or two just to give a flavor, but then the price tag probably I won't. One of them is about actually this kind of a low cost monitoring of urban mobility, city environments, kind of, I would say, uh, pollution, and then kind of accident prevention type of monitoring, where you actually can deploy edge devices across the city, depending on whether it's base station or kind of gateways that people can deploy. And then you can actually, with a very nice design, you can actually have a nice low cost coverage to track certain kind of, uh, mobility trajectories and also the kind of particles for environmental monitoring. So that kind of things are already, there are several countries, partners I know, they have active projects on that front. So that's more kind of a bit away from, this is not TikTok. So absolutely, we are not seeing TikTok on edge yet. So, but that's actually where we first see kind of infrastructure based applications first on the edge. And then in terms of end user type of angle, for edge. Another thing we might see in coming years would be about, if the real metaverse whole thing start coming up, and then we have a lot of demand for gaming, more kind of pervasive style, in kind of deeply virtually augmented powered type of thing. And that's where the edge actually can provide a lot of kind of services, empowering that type of services, which requires loads of data to be collected, uploads, downloads from your gadgets, on your glasses to the cloud. And then the infrastructure as a whole will never be able to kind of, immediately creates capacity to support that demand. So the edge is actually one of the very interesting platform in the middle, directly handling that part. So basically, yeah, your communication will be directly processed by the first hop device, a gateway or base station, so that without actually congesting the entire internet infrastructure. So in that case, I would say I throw two type of potential services that are somehow relevant to this. So price tag wise, I could not say anything, but then uh, to be aware, edge computing is like an infrastructure. So it is not like end devices we have. So you are not going to see any kind of the what we typically see mobile gaming apps so far so fast on the edge. So infrastructure apps are the first category, and then later there will be also more kind of a gaming multimedia type of devices. And then yeah, if you go to actually the public space, kind of healthcare monitoring, hospitals, that's actually already also kind of a different kind of sector where there is also kind of a potential in edge services.
Okay. Thank you for this answer. And yeah, the metaverse point is very relevant.
Mhm.
So there is a more practical question. How do we access edge services by IPv6, and which
Ah,
programming languages should I learn for creating edge services?
yeah, I would say at the moment, edge computing part is not actually about protocol. So the infrastructure is actually, they are overlaying on the existing kind of deployments of the network access. So in terms of wireless communication, essentially what your providers provided you, either over IPv4, IPv6, I think that's more about, the pipe where you actually getting your kind of connections to the edge kind of a device for programming certain apps and services. So I would say in the future, clearly IPv6 would be definitely the preferred version. But then you never know. IPv6 is not the final version. Maybe there is the future IPv6 or the next version of that. So in that case, yeah, this part I would say it is
Okay.
pending. So
Yeah, it's linked to the services and to the device, I think.
yeah, exactly.
And for the programming and for the programming languages, is there a standard like Python or something like that now, or is it still
For
open?
that one, yeah. I would say at the moment there is no actually dominant language that actually people do with edge. But then if you think about more about edge machine learning, edge AI, uh, because of the popularity of this PyTorch and things
Python.
like that, Python actually was somehow from the academia point of view, we observe more and more kind of existing groups are using that. So for the future, if you are referring to developers start working on that, I think that's actually not yet easy to predict. So, and
Okay.
of course, depending on later the companies, if Microsoft doing this, if Amazon doing this, Apple doing that, start actually pushing their edge potential services deployment framework, and then the language probably is also somehow attached to the preferred language of their platforms. So it can be C sharp, it can be C++,
Yeah.
it can be Rust. So
Yeah. So maybe there will not be yet an unified language for having edge
not yet,
services on
as far as I
every.
see. Mm.
Well, and
Okay.
maybe related to that, we talked about it already, but to hear it maybe clearly once again. So when we talk about edge services, so let's take your lamp posts for instance.
Yeah.
Do we talk about fully edge slash distributed services where the databases are also
Yeah.
distributed, or are these hybrid services where you also had cloud parts?
Mhm.
Maybe this is interesting also for the audience.
Indeed,
Maybe
yeah, that's
also
a good
know
one.
about.
Yeah, I like that. Uh, I would say maybe it's hard how to say the final, the ultimate version, how that would be. But at the moment, the most kind of realistic one is kind of what you said, hybrid one, where the lots of intelligence now going on the edge, like lamppost. But then there is still fallback because lampposts typically have fibers attached to the internet. So the cloud is always there in terms of certain backup, certain kind of emergency, and also in terms of actually training, I still think that for privacy reason, still we need to have a cloud, and then somehow you actually to actually get maybe not directly raw data from different sources, but actually the parameters and also the weights collected by different edge devices. So in that case, uh, completely going to the peer-to-peer modes, decentralized mode, uh, I would say academically very appealing, but realistically, that might not actually fit very nicely with all the services that we are going to, because sometimes, yeah, we have a joke. Academia don't make apps, so we don't make apps for money. But then that's actually essentially, if you only listen to one side, it may not actually be, kind of, reflecting the future trends.
Mhm. So time is already advancing. So Alex, I think we'll have time for two to three more questions, and I take the freedom again to pick one because I think this is also very interesting for the audience. So you were talking about trust,
Yeah,
but you did not define your understanding of what you mean with the term now. And could you say
exactly.
something more about it and what
Yeah.
exactly, which notion of trust you
Mm.
find especially interesting at the moment for the edge computing?
Yeah. I did not actually put the trust definition on paper in the slides because that's actually where the chaotic stuff happens. Because trust starts, from the social science and the humanity domain to begin with. It's about human kind of, trust, and then now we are talking about in a kind of a digitalized sphere, and then in the future we have a more kind of, digital human kind of fused version. So the trust actually the definition that evolves very rapidly, and then putting any definition on the paper now, we have that in paper, of course, that's for reference. But I actually try to stay away from, just giving, because I know, yeah, in computer science engineers we want to have 0 and 1. We want to see, this is what you say, and then, but it does not make too much sense. So, but I can say something about trust for edge computing and edge AI at the moment. Uh, it is actually a concept where we need to actually take into account several elements to form this trust concept. And then in that kind of, at least I point out for edge AI, there are three parts we need to pay attention. That's actually our essence of the trust of edge AI. It's about the transparency in terms of the algorithms that deployed inside edge, and then how actually certain decisions going to actions being made, where does actually that problems happens, and then if it is possible actually for, developers, for the operators to explain the actions. So what if that's, your car is diagnosed as a kind of, stolen car by some cameras on the road, and then the algorithm decided that uh, the process actually, if it is by a kind of deep learning model, it is actually at the moment not very easy to, pinpoint and transparently what is actually the problem. Where does it come from? Is it because of training data set that's problem, has bias, or is it because the parameters, the kind of the deployers put it install on the system, they put the wrong parameter, the threshold wrong? It's pretty difficult. Or the algorithm itself is completely corrupted. And but then, yeah, that one is even more kind of more tricky. Transparency is one. Second one is fairness. And this is where on the edge AI in the distributed environment, we need to pay attention. Nowadays, when you take away the services on the cloud to the edge, you have to shrink something. You have to cut off, kind of, compress it a bit. The absolutely there is some cost. And at the beginning, people try to trade off the accuracy, but at the same time, nowadays we realize it's not just accuracy people are trading off. When you compress, when you actually pack more things on the edge, it is also the bias that actually becomes a problem there, because sometimes people do not even realize if you compress a bit, accuracy may not lose too much, but then the whole thing becomes super biased. So like the, maybe a generation, different kind of skin color and these kind of things there. So that one is not accuracy you can easily tell by just if you do not even know where to look at. So that's the fairness part. The third part is, of course, cybersecurity related. When you put things on the edge, there is a kind of a huge kind of a security risk where it is not becoming reliable, not robust anymore. Because I have been running even back in Munich, some servers or some kind of sensors outdoors in Munich, and when temperature changes, when the things becomes, the whole operating becomes funny story. The sensors become, completely screwed. The computing have so many errors that we don't even know where this come from. And then, yeah, of course, the things, the L things, the edge is actually sometimes deployed in such kind of environment. If you think about the lamppost, the traffic lights, they are sitting in front of the snow, in the rain, in the fog, and then the whole kind of operation environments make it very unreliable. if there is no kind of design for enable that, and if we do not even know we need to prepare that certain things from that operation environment, we might actually have a bigger problem in terms of this reliability, robustness, which in the end affects the trust. If it is not reliable, I mean, I would not use any edge service if it is unreliable, if it is knowing, right? So that's why I do not actually put a very black and white
Mhm.
definition for trust.
Mhm.
But then there are certain elements we have to consider.
And I like the answer a lot with the transparency, fairness, and security or cybersecurity.
Mm.
And another dissection could, which you also said, but just to say it again, is provisioning or providing of services so that the functionality is there, and also treatment of data. Because as you said it a little bit, as if you have distributed learning, for instance, the visibility in each of the nodes might be limited, and at the same time, there might be, when we come back to cybersecurity, attacks against a certain node. And
Mm.
there, where you aggregate, as you do compression inherently, in the sense that you don't have all the meta information you had at the local node,
Yeah.
it's quite challenging and difficult to federate this information to a picture that is reflecting reality.
Exactly. Yeah. The debugging problem is very much getting bigger when things move to the edge, because now you can see already how to actually track the bugs and debug
Mm.
from where. So
Exactly. So, Alex, maybe one, two more questions. Which ones do you select?
Yeah, sure. So there would be two topics for this question. The first one is energy saving. So let me check it. Yeah. Is it still possible to nowadays to have some hardware advancements in energy saving?
Mhm.
And the second related question is, how can we achieve energy saving? Who has to be active, if it's company, users, European Union,
Ah,
governments, associations, for instance? So the
indeed.
granularity of energy saving and the hardware versus software energy saving.
Mhm. Well, that's a very big question, but yeah, I try my best to answer, to the degree I can. So first of all, for the hardware problem, uh, I would say now the chip design is actually going to the direction where we would like, in terms of energy saving, because we are benefiting from many years of the smartphone, kind of the different chip makers and also the software developers, because essentially saving energy on the car, on the other edge devices are more like, we're talking about similar things like the smartphones. And then uh, energy parts on that front, for the chip, for the hardware, I think, yeah, nowadays we are actually, can somehow pretty much use existing chips that actually are pretty mature in terms of energy saving, and also for the software stack on the Android and on the maybe similar kind of operating system, that they are actually are pretty capable to supporting certain part of the, from that hardware perspective, the energy benefits that when we deploy edge computing kind of infrastructure in order to run services on top. So hardware side, I would say we are not too bad at the moment, because there is a lot of inheritance from both the design of the smartphones, and even also the cloud data center provides loads of interesting protocols, designs, many years of experience how to save energy. For example, they throw the data center into the Nordic countries, using the water, using the kind of cold wind. Those are millions of questions, millions of lessons that can be learned from. And then for the hardware, that's the best I can provide now. And then on the second part, you are asking more kind of extensive questions regarding the energy parts for the future, how we actually do that granularity wise. I would say we have to take it step by step, because this is one of the problems I faced in my project when I started looking at the vehicle, for example. Uh, Sometimes people, before looking on the problem, just by looking at the problem from outside, you never know the complexity in it. For example, what if that we deploy certain thing to save energy, but then at the risk of making the safety of the cars less? So what if we are going to maximize the energy uh, that edge can support, but at the same time makes a lot of security holes in the system? And this is actually the complexity where I would say it is case by case. And then at the moment, we do not have actually a clear kind of a silver bullet or golden standards to categorize, on this, on that granularity. certain things that are kind of more kind of energy friendly, or certain things are more kind of energy hungry uh, to be deployed on the edge. So I guess this is at least from my understanding and my experience now on this sustainability part for the edge computing. But of course, one thing I need to point out is that I already lay out on that map is that energy saving is not the only problem for sustainability in edge. There is also kind of more problems in terms of this ecosystem cycle recycling and also the cycle management of the edge device software data that we are going to have, because that's actually one of the problems even for IoT. Nowadays, we have loads of more and more IoT waste here and there deployed across. And the edge computing, those devices, if they are distributed kind of randomly, and we need actually human to manually manage them, that overhead is actually way much higher than people can think. So frankly speaking, I would say sometimes many years ago, I deployed a couple of sensors across two Munich campus. Just over half a year, we don't even remember where they are, and then they're just secretly somewhere in the building. And then yeah, you never know. What if they are hacked? And then what if actually their battery leaked there? So this is kind of another sustainable issue in this edge computing we cannot get rid of as well. So.
Okay, thank you. And to finish, a question more about research. So they are very open question. We do not wait for very precise
Ah.
answers and very short answers. So, do you think that do you recommend that we have to work on applied or fundamental research on edge computing? And what is, according to you, the most exciting aspect of your research on edge computing?
Interesting, yeah. Fundamental research, I think that's always needed, because I think in this case, we are actually in this edge computing, edge AI domain. Uh, Even though we actually borrow a lot of things from clouds, from IoT, from mobile computing, but then certain problems actually are very new, depending on the new requirements of the user, the device, and then the new larger volume of data that we never seen before. That you never know. In 1 or 2 seconds, there were several terabytes of data you have to immediately process. So those are kind of a harsh new requirements that we need actually a fundamental kind of a look in terms of design, theory, algorithm, and also even maybe also about the operating system, programming, and also paradigm and models, how we actually look at, I would say kind of a evolving cloud edge IoT in the future, because at the moment, I guess people are very much familiar with the programming on the device, mobile phone, Android, and nowadays more people more familiar with the cloud paradigm, serverless, for example. But then now, when the edge actually becomes a new kind of a interesting new paradigm, it is actually also kind of unclear how we are having any fundamental new software engineering type of design for that. So I would say, yeah, clearly needed. And then of course, edge AI, edge computing is a very highly applied domain. So I would say that instead of lock every one of us in the basements just looking at some mathematic formula, we should actually embrace industry and also critics from industry as well, because that's I would say one of the benefits in the past 10 years where clouds benefit a lot, because they have a very open kind of academia kind of a, I would say, business industry collaboration, which made a success. I think, yeah, for edge computing, I would say, yeah, definitely fundamental research together with more kind of practical oriented industry flavor of investigation R&D, they are both needed.
Okay, thank you. And so to finish, the most exciting aspect, according to you, to your research on edge
Mhm.
computing?
Yeah, yeah. For me, at the moment, uh, depending on how many years you are looking ahead. So in the upcoming 3, 4, 5 years, I'm still working heavily, and I find it very exciting to actually dive deeper into the energy saving and also the trust part, which is related to the cybersecurity of the edge AI. So those are the very exciting subjects. And then even looking beyond that, I think, yeah, uh, there will actually more problems probably will be created once we are improving the edge towards a certain degree, the new problems will arrive. And then in that case, we are probably going to face the new kind of computing challenges in terms of this decentralization. And then also the quantum computing probably will also having some impact in the future years, which has a cascading effect on all the cybersecurity practice we're having. And then I don't think edge is excluded from that. So that can be foreseen as a certain potential challenges we are going to both see as maybe opportunity as well, because that's also kind of depending how we play that. So
Okay, thank you for your answers, and thank you again for your presentation. And back to you, Mark Oliver.
Well, thank you very much, and thank you very much, Alex, for the fantastic question moderation, and also thank you to Renzo, who was in the background moderating the different live streams on YouTube, LinkedIn, and Facebook. Yeah, so the time was flying as always in this series because it's a super exciting topic, and I'm especially happy that we could do this session today with you, because you really shared your expertise as one of the leading scientists in that field, I would say, at the moment. So it was really nice listening to you, and to explicitly say it again to our audience. So the link to the cybersecurity, besides all the aspects that Aaron was talking about, like trust, AI, and so on, is that edge computing is really the paradigm that is today the thing where computing goes. That means the applications that we secure from the cybersecurity side are those that use this edge infrastructure, and therefore all the challenges that we were talking about are in the series, and also today are on this kind of infrastructure, and therefore it's super important to get some understanding, and you perfectly delivered this understanding with your mix of basics, and especially also in the discussion and applications and outlook. So thanks a lot, Aaron. It was a fantastic addition. Thank you very much.
Yeah, same here. So yeah, I really enjoy this kind of way to organize, and I have the chance to share some of the latest interesting insights. And then yeah, I guess the fundamental message I want to cross is that I want to stay critical also, because for edge computing, edge AI, one of the mistakes is that everybody think I'm actually a believer, and it's more like a marketing speech every time. But no, actually, I'm even more critical than you can imagine on these subjects. And then that's why we are trying to dive deeper into actually, let's see how deep the rabbit hole goes this time.
Very good. Very good. So that brings us to the end of today's edition, and the next edition, which will actually be already next week, or 2 weeks. Yep. We'll have on the 7th of November, which will be a Monday, and at that time at 10 o'clock, I'll be very happy to welcome Gabi Trio from the University of Armed Forces in Munich, and Gabi will be talking about paradigm shift from cybersecurity to cyber resilience. And those in the stream, you have the chance to watch now the trailer. As usual, share the info about the format with your friends, so that we have more audience in the future. Subscribe to the channel, subscribe to the news on the website, and most important, keep the discussion on cybersecurity-related topics, because without it, our society is really lost. So see you in 2 weeks. Have a great time, and see you soon. Stay safe.
My talk will be about this paradigm shift from security to resilience, and especially also the ways, the steps, the obstacles, chances and risks, what to do to get a cyber resilient system. Cybersecurity is necessary to think in another way, and certainly in terms of cyber resilience. Since we cannot build 100% secure systems, as we all know, the question is how we can build robust systems that the overall functionality is provided, also in case some parts are failing.
Cher cyber-CNI, pôle d'excellence région Bretagne. Au revoir et à la prochaine.